Okay, a quick little demonstration here of the International Space Station orbit. Why you can see it sometimes, why you can't see it sometimes. This is the orbit. This isn't accurate. It's a little simulation. I'm using Universe Sandbox2 to kind of show this. But here's the International Space Station. Here's its orbit. It's 51 degrees inclined to the equator of the Earth. Northern Hemisphere, Southern Hemisphere, the Earth. I'm going to go ahead and start the simulation. You can see what the International Space Station does. As it comes over, it's in daytime now. It's the sun. Here, let me pause it. Let me show you what I've done. I've put three objects in here. I put the sun, the Earth, and the International Space Station. So we're just kind of facing this direction right now. Who knows if it's, the seasons or whatever. It really doesn't matter. But the International Space Station is going across the equator. It's going south. It's going to go into Earth's shadow here in just a moment. This will be nighttime for that. It's going around the dark side of the Earth in shadow. It's going to come out right here. This is morning time for sunrise for the people on the space station. This is their sunrise. As they come out of the dark side, they hit this side, sunrise for them. Now let me turn on the flashlight here and we'll see who could see it. Who could see the space station right now? Well, it looks like Japan. It's kind of over Japan right now. So in the morning, Japan, yada yada yada, they'd be able to see it. Let's go back to realistic. Go ahead and hit play. And of course it's in daytime. It's 45 minutes in the day and 45 minutes in the dark, in the shadow. Let me speed up. There we go. Okay, we'll stop it right there. And let's see. Oh, it's down here. Let's play the simulation for just a moment and let it get back up to sunrise. It's coming around in the shadow of the planet. And it's going to pop out right about now. So it's sunrise. Whoops, pause. It's sunrise for, this half of the Earth. Looks like the United States here. This is the East Coast. Let's turn the flashlight on and just kind of see. Yeah, so the orbit line is coming over Florida. This would be a good time for Florida to launch if they wanted to rendezvous with the International Space Station. They would launch when they were directly under the orbit. They launch in this direction and catch up with it. Rendezvous with it. That's how they would do it. There's a certain window. You don't want to launch when you're not under it because then you have to change your orbit. It's going to use more fuel. So the International Space Station orbiting. It's over the East Coast right now. So if we were in Virginia, and it was realistically, this is the day-night terminator here. This is daytime, nighttime, morning, early morning, 3, 4 o'clock in the morning, to the nighttime, which would be 9:30, 10, 11 o'clock, depending. You can see that because it's over the East Coast, this is a good viewing time. Probably Virginia would have to look southwest to see it. It's coming from the west. It disappears into the east, of course. This would be a good time to see it. Let me turn back on the flashlight here so you can see. And since it's doing it every 90 minutes, it'll be back over here in 90 minutes. Of course, the Earth will have turned, and it'll be over a different part of the United States. Sometimes I'm in Virginia, and if I see it in 90 minutes, it should be over, New Mexico. My son is in New Mexico, so I'll call him and say, hey, look for the space station. Should be flying over in about an hour and a half. So recently, so this is why you can see it. Sometimes, if the orbit line is north of Virginia, you're going to look northwest to see it. But so right now, you might be able to see it southwest. And you should be able to see it for about 3 or 4 minutes, depending if you're in the plains or if you're in the mountains. Your horizon may be a little bit different. so you wouldn't be able to see it as long. I know sometimes I just look towards the west, mainly towards the west, and I'll see it, but sometimes I see it northwest, sometimes I'll see it southwest. So if you're lucky, you might be able to get to see it twice, once in the northwest, once in the southwest. Just depends on the timing of the weather, of course, and where it is over top of the Earth. Now it's in an inclined orbit, 90 degrees. It does this. I'll speed it up a little bit so you can see the Earth turning and how it goes, how the Earth will spin, and it'll be over top of a different part of the United States. So probably people in California, Washington, maybe Washington will be able to see it when it comes up. They would be looking a little bit southwest to see it right now. California would be able to see it. Of course, that would be in the daytime already. Oh, I got the flashlight on. Realistically, the day-night terminator would determine when you can see it, if it's over top of your state or area. Now, you can go to Iss Tracker. It's isstracker.com, and you can see exactly where it is at this moment. Looks like it's it's in the dark. It's getting ready to come out in the daytime. So Australia would be able to see it. Here's the day-night terminator. Right here, 17,000 miles an hour, 250 miles up. You can also go to spot the station, select your location wherever you are, on the planet, and get the viewing times for the week. It was out this morning at almost 4 a.m. You could have saw it for about 6 minutes. It's really cloudy. It was bad weather this weekend. And again, you could have saw it at 5:34 a.m. for 5 minutes. Now tonight, it is the 22nd of July. Tonight you can see it at 10:15 p.m., but you only get a couple of minutes of viewing time. Look northwest to see it. Recently, I have witnessed something. Where's the station at? Let me hit play here. Recently, I frequently look for the International Space Station. I'm always looking up. I will see an object that's in a polar orbit. Now, the polar orbit is inclined to about 90 degrees and 89. So, here's Virginia. Here we are here. I will see it. It is traveling from the north to the south, almost directly. It's not exact, but it's almost directly from the north to the south. So that means whatever it is in a polar orbit. I know it's not an airplane. I know it is an object that's in space because of the speed. It's almost traveling the same speed as the space station. I get a couple of minutes to see it, and of course its lights aren't flashing. It's not a plane, so no jet sound. But it's traveling north to south. So if you're out and you see it, look early in the morning, 4 a.m. till morning, or at night, and see if you can see it. But let me hit play on this. You'll see that you have to be in the right angle or the right position to see it. Polar orbits are good for if you're going to take a picture. If you're going to image the entire Earth, you want to take a picture of the Earth every second. You're going to eventually have the entire Earth covered, because you're going to be taking a picture. Let's say you start right now, it's daytime. You start taking a picture, you're going to get a little bit of California. Okay. A couple of days from now, you're going to get the rest of California. You're going to get other parts. So polar orbit, something is in a polar orbit, and I've been able to see it. If anybody else is looking up, see if you all can notice it. From north, almost directly north, almost directly south. I don't know what it is. I've done some searches for polar orbits and what we have, maybe NASA has, in a polar orbit. It could be weather satellites. I have no idea what it is, but it was just interesting to see while I was looking for the space station. And you can still see some meteors hitting. If you're out early in the morning, late at night, look up. You might see the meteors hitting. Anyway, quick and dirty, International Space Station orbit. Thanks for watching.